class-10Example.
Second question is when in the form of 4q plus 3. So case second, n is equal to 4q plus 3. So what is the value of n square minus 1? Similarly solve 4q plus 3 whole square minus 1. So it is 4q square b square plus 2 into a into b minus 1. It is 16q square plus 9 24q minus 1. Then it is 16q square plus 24q plus 8. Now find out 8 is the common. So 8 is the common, then you get 2q square plus 3q and plus 1. Then it is clear. It is a multiple of 8. So it is divisible by 8. Hence we can say n square minus 1 is our integer n. Then it is divisible by 8. Thank you. Remaining video next day. To e-learning classes managed by Modern English School Nevada. Dear student, myself Vijay Kumar, your mathematics teacher, Modern English School, New Area, Nevada. Dear students, in previous 2 lectures, I solved some examples and theorem related to Euclid's division's lemma. Today, remaining questions of exercise 1A of examples today solved, and these questions are very important for the view of examinations. So dear students, see towards the boards and follow me. That is, using Euclid's division's lemma, so that a square of any positive integer is either of form 3m or 3m plus 1. Your question is, it is positive integer 1, 2, 3, 4, 5, 6, 7, etc. 8. It is a positive integer. A square of this integer is 1 square, that is 1, 2a square, that is 4, and 3a square, that is 9, 4 square, that is 16, 5 square, that is 25, etc. Your question, you can write this like as 3 into 0 plus 1. This is right 3 into 1 plus 1. This is right 3 into 3 plus 0. This is right 3 into 5 plus 1. This is right 3 into 8 plus 1. Dear student, to find out all in the form of 3m plus 1 or 3m. This is 3m plus 1. At the place of m is 0. It is 3m plus 1. At the place of m is 1. It is 3m because here is 0, so it is only 3m. And it is 3m plus 1. It is also 3m plus 1. Here is 36. Then you can also write 3 into 12, and it is in the form of 3. So it is clear every square of the number we can write in the form of 3m or 3m plus 1. But by theorem, how you can solve the square of any positive integer in the form of 3m or 3m plus 1. So you write, let a be any positive integer divided by 3, we get, here is 3m or 3m plus 1, because after squaring you get this. So never suppose m is the constant, so you get q is the constant, q is the constant, r is remainder, r is remainder. So what you get? You get a divided by 3 q and r. So a is equal to what? 3q plus r, where r is greater than equal to 0, less than 3. So what is R? 0, 1 and 2. Because divided 3, so remainder is always less than 3. So first case first, there are 3 number possibility. First 3 cube, then remainder is R, 0. Next 3 cube plus 1, then remainder is 1. And third 3 cube plus 2. So there are 3 number defined. When any number divided by 3, any positive integer, when you divide by 3, then there are 3 conditions. Already you solved in example 2 of this exercise, that any number divided by 3, then you get it is 3m plus 1 or 3m plus 2. Here we discussed that it is the m at the place of q, and it is 3q plus 1, 3q plus 2, it is possible. Now your question, when it is squaring it, there are 3 conditions, and you find out squaring one by one 3 times. So first is 3q. Yes, first you write yes first a is equal to 3q. When you are squaring, then you get a square, then it is 9q square. Hence you write a square is equal to 3 into 3q square, and it is 3m, where m is equal to 3q square. M is the variable, so at different time m is the different. So m at the place of 3q square, write m, then it is in the form of 3m. So your question is either 3m or 3m plus 1. So first case, it is in the form of 3m. Similarly, case second. Now a is equal to 3q plus 1. So a square is equal to 3q plus 1 whole square. What you get? You get a square is equal to a square plus b square plus 2 into a into b. You write here 9q square plus 1 plus 6q. You write, arrange it, 9q square plus 6q plus 1. 3 take common, 3q square plus 2q plus 1. Now, you suppose it is m. So what you get? You get 3m plus 1, where m is equal to 3q square plus 2q. Now m is changed. Here m is 3q square. Now m is 3q square plus 2q. Here m is the variable term and a different term in different cases. So in first cases at the place of 3m, in second cases 3q square plus 2q is m. So now it is the form of 3m plus 1. And last case is 3q plus 2. So case third, a is equal to 3q plus 2. So what is a square is equal to 3q plus 2 whole square. What is it? A square plus 2 into a into b plus b square. So it is 9q square plus 3 to the 6, that 12q and plus 4. Now arrange in the form of 3m plus 1. So how we arrange? So we write it is 9q square plus 12q plus 4. But here is not 3m plus 4. So we arrange it like as 9q square plus 12q plus 3 plus 1. Now what is the common among them? That is 3. So it is 3q square plus 4q plus 1 and plus 1. Now suppose it is m. So 3m plus 1. Where m is equal to now 3q square plus 4q plus 1. So now we have to change. So in any case, when you divide a by 3, then you get 3 cases, that is 3q plus 1 and 3q plus 2. And squaring them, then you get this 3 condition, that is 2 times 3m plus 1 and 1 times 3m. Now example 6 as example 5. In example 5, by using Coulomb division, show that a square of the positive integer in the form of 3m plus 1. But in these questions, now show that the cube of any positive integer is of the form of 9m plus 1 and 9m plus 8. Both are the same questions, slightly difference between them. That in question number 5 is the square of positive integer, and question number 6 is cube of the positive integer. Starting both are same. So as example 5, you write when t divided by 3, then solution you write A is positive integer in the form of 3 cube plus 1 and 3 cube plus 2. You know, in previous questions that any number divided by 3, then there are 3 remainder, 0, 1, 2, quotient is cube, then when remainder is 0, then that number is 3 cube, when quotient is 1, that number is 3 cube plus 1, and when quotient is 2, that is, then number is 3 cube plus 2. Now case 1. Case 1. A is equal to 3 cube. The question is cubing both sides. So A cube is equal to 27 cube. You write 9 into 3 cube. So it is 9m. The questions here 3 cube is equal to m. So first condition is okay. Now case second. A is equal to 3 cube plus 1. Again cubing. So A cube is equal to 3 cube plus 1 cube. What you get? You get here A cube. Here is A cube plus B cube plus 3A B bracket A plus B. It is the formula of A plus B whole cube, A cube plus B cube plus 3AB brackets A plus B. Then it is 27 cube plus 1, 3 is 9, 3 is 27 q square plus 9 cube. Now arrange 27 cube plus 27 q square plus 9 cube plus 1. Here 9 is common. So 9 common, then 3 q square, and it is q plus 1. Now suppose it is m. So what is your question? It is 9m plus 1. Here m is equal to what? M is equal to 3 cube plus 3 q square plus q. So to the place of 3 q square is m, then it is the form is 9m plus 1. It is second case. Similarly, when third case, that is 9 cube plus, when third case you write A is equal to now 3 cube plus 2. So cubing both sides, then write A cube is equal to 3 cube plus 2 whole cube. And here you write A cube, again A cube plus B cube plus 3AB brackets A plus B. What you write? It is 27 cube plus 8 plus 3 is 9 to the 18, 3 is 54 q square, 54 q square, 3 is 9 to the 18 to the 36 cube. Now arrange like as, so arrange it 27 cube to the power q plus 54 q to the power 2 plus 36 q plus 8. What is common movement? That is 9. You take 9 as a common. When you take 9 as a common, then it is 3qq plus 6q square plus 4q and plus 8. Hence, you write it is 9m plus 8, where m is equal to 3qq plus 6q square plus 4q. So, when you cubing any positive integer, then there are 3 forms and 3 cases. First case you get 9m plus 1, 9m plus 8. But dear students, your question is 9m plus 1, 9 plus 8. But you take integer in the form of 3q, 3q plus 1, 3q plus 2, as like questions number 5. Now see questions number 7 and 8, both are the same. I solve 7 and remaining 8 you solve it by this method. Here is so that one and only one out of the n plus 1, n plus 2 is divisible by 3, where n is any positive integer. Your question is n is any positive integer, then from 3 form n plus 1 and n plus 2, any one divisible by 3. Any number, keep in mind 15, 16, 17, 23, 24, 80, 90, any number at the place of n, then you find out that one and only one number is divisible by 3. So suppose we write 20 n. So what it is? You get 20 plus 1, it is get 20 plus 2. What you find here? You find here from 3 process, only one, that is 21, is divisible by 3 and other is not divisible by 3. So your question is that at the place of n, you write any positive integer, then one and only one from this form, n plus 1 and n plus 2, one and only one is divisible by 3, another is not divisible by 3. Suppose here is 21 now. Now here is, question is 28. What you get? Here is 28, divisible or not? Here is 28 plus 1, that is 29, divisible or not? Here is 28 plus 2, you get 30. Now it is divisible by 3. So from 3 process, 1 is divisible by 3. How you can solve it? You take like as, let n is any positive integer in the form divided by 3, we get q is quotient and r is remainder. What you get? You get a divided by 3, r is remainder, q is quotient. Then a is equal to 3q plus r. So there are 3 conditions, that is r is greater than equal to 0 but less than 3. So r is only possible 0, 1 and 2. So what is the condition of n? So n is 3 times. One is 3q, other is 3q plus 1 and last is 3q plus 2. Your question is one and only one divisible from these 3 cases. I suppose case 1, that is n. What you write? That divisible by 3 and you have 3 options. So at the n you write 3q. So you write, so it is divisible by 3. Case second, now n plus 1. So what you write here? This option you have 2 only. So I think you write this. It is 3q plus 2 and plus 1. That is 3q plus 3. Then 3 is a common. Then it is q plus 1. So it is clear. It is divisible by 3. So we write it is divisible by 3. And last case is n plus 2. So last case, case 3. And your option is n plus 2. Remaining, you write here n plus 2. Then you write this at the place of n. 3 plus 1 and plus 2. What you get? 3 plus 3. Take 3 as a common. 3. So it is divisible by 3. So it is clear that there are 3 options you have: 3q, 3q plus 1, 3q plus 2, and there are also 3 options to put their value of n. So one by one substitute the value in the cases first, second, third, and you get your solution that 1 and only 1 is divisible by 3. That's all. Now this is the last examples of this exercise, example 9. That is, if n is odd integer, then show that n square minus 1 is divisible by 8. n is odd integer. Integer is 1, 3, 5, 7, 9. It is odd integer. When it is the form of n square minus 1 means 1 square minus 1, that is 0, divisible by 8. Next, 3 square minus 1, that is 9 minus 1, 8, divisible by 8. It is 5 square minus n, that is 25 minus 1, that is 24, divisible by 8. 7 square minus 1, that is 49 minus 1, that is 48, divisible by 8. So it is clear, the square of any odd integer and subtracted to 1, then it is clear it is divisible by 8. But how you can solve by the theorem? Theorem means you take, let n is any odd positive integer in the form of 4q plus 1 and 4q plus 3. Now your question in your mind that why it takes only 4q plus 1, 4q plus 3, no other than this. In your previous chapters you read there are so many odd numbers like as 2q plus 1, next 6q plus 1, 6q plus 3, 6q plus 5, and 4q plus 1, 4q plus 3. But why take this? Because when you are squaring it, then never you get it divisible by 8, because the squaring is only 4. Similarly, here is the squaring, you get 6q plus 3, then you get 36, so it is not divisible by 8. So thinking we take that it is 4q and it is the squaring, then you get 16, so it is divisible by 8. So I take only odd number. For in these questions, you take always 4q plus 1 and 4q plus 3. Now substitute their value. Case first, n is equal to 4q plus 1. 4q plus 1. So what is the value of n square minus 1? You write here 4q plus 1 square minus 1. Then a square plus b square plus 2 into a into b minus 1. Here is 16q square plus 1 plus 8q and minus 1. Cancel. That is 16q square plus 8q. 8 common, then it is 2q square plus q. And it is clear, when 8 is common, then it is divisible by 8. So you can write, so it is divisible by